octet, all 8 bits in the third octet are turned on in the 32-bit mask. That means that's our network. Then the last 8 bits represent the host. Now in the table it said that your hosts, all your possible hosts was 254. But we know with 8 bits that the possibilities are 256. Well, what happened to the other ones? You got 2 that are missing there. Well, here's what happened to them. 192.168.101.0 is the actual network number. Okay? If it's a letter to my mom, think of it as the actual city, state, zip code that she's in, the region. And also 255, or if you turn all these bits on, 255 is what's called the broadcast. In other words, if I want to send a packet to everybody, to every host, every node on the 192.168.101.0 network, then I would simply use the address 192.168.101.255. That's the broadcast address. Every network has a network address, .0, and a broadcast address, .255. Therefore, since I can't use the network and I can't use the broadcast, that only gives me 254 possibilities. That's why for every Class C address, you've only got 254 hosts. And that's really important because if you go to an ISP and you say, I want a public IP address that can make my workstations and servers and laptops and other stations visible with routable IP addresses to the public internet, if they give you a Class C address like this one, you've only got 254 addresses. So if your company grows beyond 254, you had to go up and buy more Class C addresses. Or you could just use a Class B that we saw earlier that has a lot more hosts per network. Okay? Fewer networks, you don't get 2 million, but you've got 65,534 hosts per network. That's why Class Bs are also very popular, especially on small to medium-sized businesses and larger organizations. So again, our Class A, Class B, Class C addresses, it's very, very important to memorize some key information. For your exam, you want to memorize of Class A, B, and C, what number is the first octet range. And they'll, of course, give you an IP address and ask you what class is it in. It also helps to know memorize how many networks you have per class and approximately how many hosts you have per class. Okay? Good information to know. Also want to know and memorize the default subnet mask for your Class A, Class B, and Class C network. So since Class A uses 1 octet for the network, the mask is going to be 255.0.0.0. Since your Class B uses 2 octets, the first 2 octets for the network, the subnet mask, the default is going to be 255.255.0.0. See the pattern? And then your Class C subnet mask, which uses 3 octets for the network, the mask is going to be 255.255.255.0. Now, it didn't take long to figure out that, you know what, we want to use the TCP/IP protocol for our applications and for our organization, but we don't really want the IP addressing scheme to make our hosts available or to make our particular workstations and servers visible to the outside public internet. We also want to have some IP addressing to use for testing purposes, for training purposes, for internal use only. So some addresses have been set aside, private addresses, reserved addresses from each one of the ranges, Class A, Class B, and Class C. So you also want to memorize the fact that from 10.0.0.0 all the way to 10.255.255.255 in the Class A range, these are private reserved addresses. In other words, if a packet that has the address of 10.1.0.0 hits a router, let's say that's at the edge of a large organization or in an ISP or a service provider on the internet, that packet's going to get dropped. It will not be routed. It's recognized as a private reserved address. Same thing for Class B. Anything between 170.16.0.0 all the way up to this address is also going to be a private address. And you've also got a range of Class C, 192.168.0.0 up to 192.168.255.255. And you'll see these addresses used whenever you're like looking at training books that are out there. Some of the addresses that are used for examples and training commonly use address ranges from these private reserved addresses. These are based on one of the documents that's used to define internet standards. It's called a request for comment, and the number is 1918, or request for comment 1918. If you just go up and Google RFC 1918, you're going to get a request for comment, and this is basically the address allocation for private internets. These are the documents used to create internet standards and specifications out there. It gives all the information here about the address space that's used for these reserved private addresses. Now, I mentioned that you'll use these addresses for testing and for lab purposes and for training purposes, but lots of companies will use these internal reserved addresses for their normal operations. Let me talk about that for a second. What a lot of companies will do is they'll go ahead and use a private network somewhere in this Class A range or Class B range, and they'll actually assign IP addresses from this private reserved pool to the hosts inside their corporate network. And what happens is they have in place some type of firewall. This is a logical symbol for a firewall. And on that firewall, they're running some software called network address translation. And again, realize that network address translation and private addressing is a mechanism that's really put in place to kind of help extend that IP version 4. Remember, there's only a finite number of addresses in that 32-bit address space, and quickly, when the World Wide Web came into being early on in the 90s, man, just the explosion, and we ran out of addresses really quickly. So network address translation allows different companies, they can use the same IP addressing scheme inside their corporate networks. You could have more than one company using a 10.10 network or a 170.16 network. But what happens is out here on the firewall, they'll have a public IP address that's valid, not from this private range, but one of the valid IP addresses in the Class A, Class B, or Class C range, and that address is used to represent their company and all of these hosts to the public internet out here over this wide area network connection. So private addresses are used for testing, they're used for training, they're used internally for private uses, but they're also used as a kind of an addressing scheme inside corporations to extend the finite number of addresses available to us in the IP version 4 scheme. Again, network address translation and private reserved addresses. Remember earlier we looked at this Class B address and this Class C address, and we realized that this Class B address, since it uses 2 octets or 16 bits to represent the host, that gives me 65,534 hosts per network. Well, think about it. You're not going to find an Ethernet domain or a local area network that has 65,000 hosts in it. So it's very likely you might want to break down this domain of 65,000 possibilities into subdomains, what we call subnetworks. If you're a small business and you've got one Class C address here, we know that we have 254 possibilities. But even my small business might want to break down this 254 IP addresses into departments. I've got my sales department, I've got my finance department, I've got my customer service department. I might want to put each one of these in their own department, their own subdomain, their own administrative network, and we call these subnetworks. Well, Well, to create these subnetworks, we have to kind of play around with these subnet masks a little bit